In the last video, we queried single tables, both in their entirety as well as subsets of them with the where clause. If we restrict ourselves to single tables, though, we're leaving a lot of functionality on the table. For example, in the previous video, we were restricting our search to the category FW, which I mentioned was footwear. But I finally know that category FW is footwear because I've been teaching this database for so long I've memorized all the foreign keys. This isn't terribly sustainable in large, complex databases that you might access only rarely, or in cases where, for example, you're producing a report for an internal client. At the same time, the names of the categories are stored in other tables, so can't we just lean on those, and how do we do that? First, let's look at the relational schema for this database, which again is Zaggy. For this video, let's pay attention to the product, vendor, and category tables. We want to make note of a few things here. First, the table and names, which we're going to need for any queries, and more importantly, we want to pay attention to the links between the tables. I see that vendor ID is a foreign key in product, and that it links to the primary key for vendor, which is also named vendor ID. I also see that category ID is a foreign key for product, which links to the category table, which is also named category ID. It's common for the foreign key and the primary key to which it links to have the same name, although this isn't always the case. Let's consider an example where we want to have all the information about each product, and then we also want the name of the vendor that supplies it instead of just the foreign key. The obvious first guess would be to say that you want to select everything from the product and the vendor table. The syntax for this would be select star from product, vendor. So if we say that we want all of the columns from the product and the vendor table together, what's going to happen is that it's not going to know how to combine the two tables. And since there aren't further instructions, the database is just going to present every possible combination of the two tables together, which is to say it's going to attach every row from the product table to every row in the vendor table. There are 2 rows in vendor and 6 rows in product, so we get 2 times 6 equals 12 rows. You can also see that it's taken all the columns from the product and then put them in all the columns with vendor. The correct answer is in there, but there's also a bunch of stuff that's not actually the correct answer. Much like if you were to empty the contents of a Dunkin' Donuts refrigerator into a blender, you would technically have the correct ingredients for a Dunkaccino, but in practice the raw eggs and the bacon would probably not be appreciated by the customer. So much like that example, we're going to want to edit this one down. The good news is we already have the tools to do this from the last video. We have the vendor ID column from the product table and the vendor ID column in the vendor table. If these two columns match, then we know that we have the correct vendor name and is going with the correct product. But we run into a problem here. We can't say where vendor ID equals vendor ID because then there are 2 columns named vendor ID. So we need to fully qualify the table names, in this case by adding the table that they're from. We can skip this as there's no ambiguity. That is to say, if the tables that we have in the from clause, that there's only one column with that name. In order to fully qualify a table name, we use the format table.column. So the vendor ID in the product table would be product.vendor_ID, and the vendor ID in the vendor table would be vendor.vendor_ID. These are 2 different columns, so it's important to specify which one you're talking about. Fully qualifying every column name isn't strictly necessary for the SQL code to work, but it does tend to be good hygiene, and several organizations which use style guides will require it. For this class, you'll only have to do it if it's strictly required. Now let's have me, from the future, demonstrate this process again, but step by step in HeidiSQL. So first, let's select everything from the product table. So I'm going to do select star, because I want all of the columns from product. And I'm going to hit F9, or I can also hit this execute SQL button. And what it's going to do is it's going to give me every single column that is in that product table. So you'll notice that there are 6 rows. So up here it says 6 rows by 5 columns. So now let's select everything from the category table. So I'm going to do select star from category. And again, I'm going to hit F9. And so now I have 2 rows, camping and footwear. And so you'll note that we have a common category ID and a non-common category name. So what happens if I select star from product and category is that it's going to give me every row in product attached to every row in category. So it's going to give me 6 times 2 rows, or 12. So notice I have 12 rows here, and then I'm going to have product 1x1, and it's going to be attached to camping. We're going to have product 1x1, it's going to be attached to footwear. And so this is what SQL is doing behind the scenes. Now, what I want it to do is only return the category name when the category ID on the product name equals a category ID on the category name. And so I'm going to have to do a where line here, where the category ID equals category ID. Except this isn't terribly useful to SQL. So I actually need to tell it, I need the product.category ID equals category.category ID. And what that's doing is I'm telling it I only want you to return the rows where this cell equals this cell. Or in other words, where the category ID in the product table equals the category ID in the category table. And so if I run that, you're going to see that it's going to reduce down to 6 rows. And all of these are going to match up. Thanks, me. This does present one small headache, though, which is that typing out table names is kind of a pain. Luckily, the people who wrote SQL also thought so and devised a way to cut down the amount of time that they spent typing out table names. These are table aliases, but they're really just abbreviations. The way that table aliases work that are in the from line, after the table name, you put a space and then the alias for the table. You can then move on to other tables subsequently. So if we wanted to alias product as P and vendor as V, we would type it out as shown at the bottom of the slide. Generally speaking, this isn't strictly necessary, but with some minor exceptions. The most notable one is that we'll run into later in this class is when we're joining tables of themselves, but let's worry about that later. Let's go back to future me to demonstrate aliases in action. So let's also make this a little bit easier on us, is that I don't want to have to type out product.category ID and category.category ID. I actually want to alias these. And so let's demonstrate the use of alias within SQL. So from product, and I'm going to say P, because this is my alias. I'm aliasing the product table as P, and I'm going to alias the category table as cat. I'm using cat because that is because there are other tables that start with C, and I tend to use standardized table names. So this way, instead of typing product.category ID, instead of typing category.category ID, I can type cat.category ID. If I run this again, it's going to give me the exact same thing. Finally, let's wrap up with a note about joining more than 2 tables together. Again, this works in the same way, just with more. In this case, we're going to have 3 tables glued together, and so we're going to need to filter out more garbage. In this case, we'd use and because everything in the scheme is connected, we could, say, list every customer that bought a specific product. At the risk of leaving with a cliffhanger, let's save this for class, though.